How's it going? My name is Raffi Krikorian. I run the application services group at Twitter. So if you think of all of Twitter and try to decompose its business logic, we have users, we have tweets, and we have timelines that sort of comprises the entire app. My group runs all the scalable infrastructure around those three things. So we build all the architecture needed to take a tweet in, fan a tweet out. We have a couple thousand tweets a second come in. We need to fan it out to a couple 100,000 people every single time one of those come in. Those might be triggered by web delivery, SMS delivery, emails might go out. We might do Apple push notifications. There's a whole lot of things that go on within Twitter, and my group runs all that infrastructure. So what I want to talk about is the story of like how we're moving from Ruby on Rails to the JVM. So this is Jack's first sketch of Twitter. Somewhere around 2006, we decided to build a website. So everyone knows what websites are. They're a collection of documents, usually served from a directory structure. They're either statically generated or dynamically generated. We have the standard REST-like commands on top of them. You're either going to do a get, a put, or a post. So that was Twitter in about 2006. And until recently, we've started thinking as Twitter more about a service. So people are generating events in real time all around the world, and we need to percolate those events through our system and act upon them in real time. So that means not just a couple thousand requests a second that we get on baseline, but handle these big, huge spikes that come in. The name of our game is real time. That's the hardest thing that Twitter has to do and accomplish. It's not an option for us to deliver a tweet a couple of minutes later. Like, we really want to get that tweet out in a couple of seconds, if not faster. So along with an evolution of our service has come an evolution of our technology. So we are probably the largest Ruby on Rails website on the planet right now. Majority of our front-end traffic is still served from Rails. Like, we have Rails hitting a bunch of back-end services, composing all the responses back, and then returning them up into the cloud. But recently, we've been thinking a lot more about moving, and we have been moving a lot of our technology over to the JVM. In fact, this started around 2008. So 2008, we moved our queuing system, a system we called Starling at the time, to Kestrel. So Starling was in Ruby, Kestrel's in Scala. Around 2008, we acquired a company called Surmise, which handles search.twitter.com. All that infrastructure is on Java. And as we move along, and as my team continues to decompose the main Twitter application, we're rebuilding all those pieces of infrastructure on the JVM. And I'm going to try to go through a bunch of the reasons why we're doing that. So I have a slew of problems. And that's interesting formatting. I have a slew of problems on my team. First off, we have a huge number of concurrent connections coming into Twitter. Like, on an off day, we're handling couple 100,000 requests a second to our infrastructure. We're pumping out a lot of I/O. If any of you has ever played with our Firehose, again, on an off day, you're talking about tens of megabits are coming out of our Firehose at any given time. All those being pushed out as quickly as we possibly can. And we have very few persistent objects. So that's basically the definition of a server workload. So the reason why I have a bird on the screen, mainly because every single project at Twitter is codenamed after a bird at some point, is we actually spent a long time trying to get Ruby to do what we needed to do. We patched the MRI. We actually built a whole new garbage collection engine to run within the runtime to make it faster and a lot more efficient for us to use to actually tackle these huge server workloads that we're getting. And we're going to continue to do this type of work. Like, we're continuing to push Ruby as far as we possibly can because our entire infrastructure has been built upon it. But we're also looking for opportunities to go and join bigger communities, find more developers, use better tools, and just evolve in a direction that the world is going in a way that we know will work well. So for that, we're relying on the JVM. So my needs. We already talked about server workloads. But as I'm going through and decomposing my application, we actually also want flexibility in language. So we're starting to pull things out of what we call our monolith. So our statuses are coming out, our timelines are coming out, our users are coming out to their own back-end services. So we want to have flexibility in all the different axes we possibly can, and language is one of them. So as a lot of people know, we run Scala for the majority of our runtime backend systems. So all our storage systems have a Scala layer on top of them that sort of handles sharding. I'll talk about that in a bit. But we also have a lot of Java within Twitter itself. And in fact, Scala and Java are two first-class languages at Twitter. We support them both equally now. A lot of our runtime code, critical path code, is in Scala. However, a lot of our relevance engines, our search engine, our advertising systems, and a bunch of other things are being written in pure Java right now. And the new kid on the block within our infrastructure is running Clojure. So we've been experimenting and toying with running Clojure more and more in production. The beauty about all this is that my ops team gives me no grief because we simply deliver them jar files to deploy and manage as long as you give them similar ways to monitor and manage all that code. So what I mean by that is similar ways to look at garbage collection logs, similar ways to get stats exported from all our runtime services, similar ways to deploy them. Our ops team really, they have an opinion, but they don't care as much as to what the engineering team may be up to. So Clojure came around with our Backtype acquisition recently, and it's something we're going to start investing in more and more. So the last thing that I want to touch upon, and what's one of the biggest reasons that we're moving to Java, is it's a real concurrency model. I know that's a kind of crazy thing to say to a bunch of Java people in a room, but I'm coming from a world where we have not the best threading model on MRI inside the Ruby VM. So it means that we can't really experiment in the ways we want to, and some real performance numbers. Right now, a single request to a Twitter API takes tens of milliseconds. We run in a request per worker model, so one request comes in, is given to a worker to deal with. That artificially gives us a low QPS that we can handle, queries per second, that we can handle per box. And it just hampers our growth. Our machine density is not as good as we think it could be. So we've been experimenting, and we've built a system we call Finagle. Finagle is our generic RPC mechanism that we've released open source for anyone to use to handle all the back-end traffic our servers can handle, as well as new incoming front-end traffic. We've abstracted away how to do asynchronous event-driven networking so we can just write beautiful and elegant code in either Scala or Java or basically any other Java JVM language we choose. And one of these Finagle servers can pump out tens of thousands of queries a second, doing the exact same thing that our Ruby machines can do. But, and I'll talk about this a bit later, we've changed our efficiency metrics because we've done something like this. So fundamentally, Twitter is a real-time and event-driven problem. We're trying to build a system that will react to the world and be able to scale as the world scales. As people talk about events, we want to handle them in real time. As one of the people who's working on the core infrastructure and manages a group of around 35 people writing the core infrastructure, we want to fundamentally rethink the way that we work on Twitter. So Ruby doesn't provide us the ability to do scatter-gather algorithms, for example. So I want to be able to have the ultimate flexibility in constructing timelines for users. So as a request comes in, I want to hit hundreds of backend machines, compose responses back, and return in 50 milliseconds. And that's something I can't do in Ruby right now. In Ruby, like you can see some of our code, we literally have to go and hit every single backend server in serial and then figure out what to do at the end with careful timeouts along the way. I just want to hit them all one shot and pull the results back. So fundamentally, the JVM gives us something that Ruby can't. So lastly, the things I trade in inside my infrastructure is I trade in RAM and CPU, I trade in bandwidth, and I trade in machine density. So RAM and CPU is obvious. We're building a bunch of systems that allow us to operate more as a cloud inside Twitter. So we can just simply launch processes into the data center and say, I need this much RAM, this much CPU. Right now, our Ruby machines, however, have the balance sort of inverted. They eat up all the RAM and all the CPU on the box, but they only pump out about 10 megabits a second or tens of megabits a second on their NICs. Whereas our Java, exact same processes written in the JVM, in fact, they look simpler, saturate a gigabit Ethernet card and use half a core. So we're sort of looking for these efficiencies. The JVM is giving me more axes that I can sort of pivot on and make real decisions on what we want to do. And because I can saturate bandwidth, and that's basically the name of Twitter's game, is to pump out as many events as we can per second, I can change my machine density counts across the data center and have real cost savings in the long run. So where are we today in sort of this transition? So our storage and retrieval layer, we've made a lot of noise about having a gizzard-based system that handles sharding, failover, and replication upon MySQL and other storage mechanisms. All of that is written in Scala right now. The next 2 layers up the stack, right now we still have the big Twitter application, which is written in Ruby. My team is working actively on pulling major components out and making that work in the JVM. However, the search team is making great efforts. They've launched something we call Blender, which is a scatter-gather for Twitter search. And on top of that, my group has something we call Macaw, which does the composition layer on top of that. So right now, the search engine says, I want to return these 100 tweet IDs. And Macaw will fetch them from our backend services, pull them together, and return them. All that is being done in the JVM. And lastly, we have our rendering layer, but that's new Twitter. New Twitter is a JavaScript system right now. We do a lot of client-side rendering. We've played with doing more server-side rendering at Twitter. And when and if we decide to go down that route, we'll probably do that in the JVM as well. So that's what we're doing with the JVM, but what are we doing on the JVM, I guess is the next question. So first off, we're rolling out our own custom build throughout our data center just to get experience on what it means to operationalize our own build at the scale that we run at Twitter. Once we've done that, our first task is to add a lot more instrumentation to the OpenJDK. We want to really understand where we should put our money. So right now, we think our biggest bet is going to be on the garbage collectors inside OpenJDK. And we've done, obviously, a lot of work in garbage collectors in the past, doing it in MRI. And we're going to continue to do that kind of work, we think, on JVM. And if anyone wants to help join us in this effort, they're more than welcome. So one thing that I really want to, and I apologize for the layout, one thing I really want to emphasize to a lot of startups out there is that switching to Java doesn't imply that we think that Ruby is a mistake. Ruby got us fundamentally to where we are today. We're somewhere between like the 9th and 5th largest site on the internet today. We have some of the best world-class product engineers who can write code in Ruby faster than anyone I've seen in my career pump out code. And we think that's really important, and we think that's really pivotal, and small companies should continue probably to go that realm. But sort of when we hit the scale that we've hit, we're pivoting as fast as we can to the JVM because there's a better community. We can hire better developers. There are better tools. There are just more resources at our disposal. So one thing I wanted to touch upon is I keep on mentioning the scale we're under and just sort of like what it actually means to really run within Twitter. So this is our TPS graph around the World Cup, Women's World Cup. And we hit a record of around 7,200 tweets per second at the final penalty shot goal. And you can see we do things like 4x spikes upon our standard baseline growth. So right now, the JVM is really the only mechanism that we can build upon that really gives us the flexibility to do something like that. So I'll be around if people have questions. But thank you for your time.